Hi, everyone. Let's get started. So before we do, any questions? Yes. Yes.
Minimum of 8 or by maximum of 8?
I would be more concerned about the content, not so much the number of pages, because that depends on the font size, the format. It's not a hard requirement. As long as you have the key elements, and if you can do it more concisely, why not? Better. You're welcome. Yes. Why? Any reason? Just does anybody endorse your request? Okay, all right, Sunday night. All right, sounds good. Anything else? Anything else? Yes. Yes.
How do we know what the good time window is for thinking it's on network failing or not?
So let's have everybody's attention. Repeat that again.
But I want the answer to the question that we had last Friday, which was like, how do we know this thing? How do we know if it's network failures? How do we know how long? Like, what if it's a delay? What's the window
For what? For what?
Don't receive like a response, like you don't get back to you, like how do we say it's a failure for sure? Because what if it's a delay and you're taking a while to just process it? When do you decide, oh yeah, maybe it's a delay?
Okay. All right. So does everyone understand the question? So what do you do in the sort of the normal commitment phases when you do prepare and stuff? So what happens if you don't collect enough prepare message, for example, or commit message? What do we do? During the normal, this is a recovery. So I'm just talking during the normal flow of the protocol when we're trying to decide on a new value that the primary is proposing. So what happens then if we don't collect enough messages? What do we do? What if we don't get enough prepare messages and we never get to the prepare state? Or we never get enough commit messages and we never get to commit? We time out. So that means we have a timer, and so we have an expectation to receive messages up to some point. And when we time out, what do we do after we time out? So at some point, we don't get enough messages, we time out, and then what do we do? We report the failure. So now, let's say R3 is one of those nodes here. So it detected a failure because you got a timeout, and then it sent a failure message. And using the word failure and view change almost interchangeably. So it sends a failure message. Okay. And then maybe later on, R1 also detect a failure, and it's also sent its own failure message. Okay. So now express your question in after this point. So what is it that you want to exactly pinpoint?
You have the same timeout standards for this recovery process too.
We have a timeout. So there's a single, we can think of that we have a single timeout. And we may, every time we get into the view change, we will sort of double it because we need to increase it. But still, you had an important question. So I don't want to, so the question is an answer, but I want you to be able to formulate it. So that's what I'm asking. That's why I kind of give the background so we can come back to formulate that question. So what is that intricacy that you want to kind of express? So we have somebody R3 detects failure, send a failure message, R1 detects failure, send failure message. And then what? So these other replica R1 and R3, they haven't timed out themselves, but they've now collected enough failure messages, as you said, by F+1. So now they know that at least one honest replica have failed. And so this failure claim supported by F+1 replica, you know at least one of them is honest. So it's legit. And then they themselves send their own failure after that point. And once we get a quorum of failure messages to F+1, then we're kind of certain that there was a failure. And we are essentially synchronizing. So we now have, whoever reaches this point, so the moment R3 reaches this point, what is it that R3 know once R3 reaches that point? No, we haven't even sent anything on the view change. So we haven't even started. Well, I mean, we started the first phase. So again, what are the two main phases of the view change? One is view synchronization, deciding on who the next leader will be. And one is the state synchronization, deciding on what was done previously, preserving all the committable transaction. So what is this point in that timeline? So it's a view synchronization. And case is blocking. Okay. So coming back to you. So what's this the question that you want to articulate? Or what was the question that we kind of ended last time? So any question on this so far? Maybe just make it simple. Is this a happy case? This is the happy case of the recovery. So what would be the unhappy case of recovery? Say that again. Okay, so what does it mean when it's not synchronized? When is it, what does it mean when it is synchronized? So when I receive a quorum, I know that the majority, what? When I construct a quorum, I know the majority, what? And what else? What else I also know, not only I detected the failure, but I know the majority agrees on who's the next primary. Who's the next primary, and in this case is PV+1. So R3 now is synchronized. If R3 is synchronized, doesn't mean that R2 is synchronized or R1 is synchronized. Exactly like when we talked about in the normal case. If I'm prepared, doesn't mean everybody else is prepared. If I'm committed, doesn't mean everybody else is committed. So this is from R3 perspective, I am now synchronized in a sense that I know that the majority agree who the next leader is, and the majority also I agree that there is a failure and we need to do the view change. Yes, questions? So at that point, what do I expect? I think I don't have it. expect the primary to propose the message, yes. And what is the new primary supposed to propose? So now the primary is in charge of making sure we do state synchronization. And so the primary bring us to the new view. And as part of bringing us to the new view is to ensure that no committable messages is lost, or in other words, preserving every committable message. Does that make sense? Yes.
One data observer, and then every other observer is set to each other. Do they also send each other the current state of their
They as part of that message, they also send everything that they have prepared and everything they have committed. I'm gonna switch slides. That's why I kind of because I think my other slides are better for this part. That is a little bit, I think, more subtle. But questions, things so you can continue thinking about that. Since nobody read the chapter 6, so let's kind of go over chapter 6. Okay. So these are the slides from chapter 6. I'm gonna skip some of it. I'm gonna take you to this page. Okay. So that's kind of the same picture that we had. At some point, R2 here in this case, R2 detected the failure. R3 detected a failure. R1 detected a failure. Yes, I just want to make sure the figure is, it's a little bit modified, but it's same principle. So this is the detection failure. These are the view change messages that are being sent. Okay. Now this becomes a critical point. There I was just showing it as a line, but doesn't necessarily mean as a line, because at this point, R3 is receiving 12+1 view change messages. At this point, R2 is receiving view change plus 12+1 view change messages, and R1 is receiving 12+1 view change messages slightly at a later point. This becomes sort of a time synchronization period. So during this phase, time is synchronized, and now the new primary is going to send out the new view in order to preserve what was done previously. And as part of the view change message, for example, the first one, I'm just going to say some random stuff or may say nothing happened. These are four rounds preceding. And so one of them says, I prepared T2. This one says, I prepared T2 and T1. This one says, I prepared T2 and T4. These are honest replica. And now the primary will kind of say, well, this is kind of random. Nobody agree on this. It will probably just ignore that. But then it says there is enough people, or at least there is one person who has said it's prepared. If it presents these three messages as the core, it says there's no conflict on what happened in the first round. Some people said nothing happened. Someone said something happened. So I'm going to choose transaction T1. For T2, the same thing. Everybody said T2. So I'll pick T2. For round 3, nobody had anything, so I just put a null. Round 4, there was one T4, and so I say T4 for round 4. And so this becomes a core And this is a consistent, it's a consistent core, and it recovers T1, T2, T4, and says nothing happened in round 3. And so now this becomes any of the identical. This becomes the new view that is sent to everybody, and all the nodes are going to update their log. So this was their initial log. This is the after the view change happened. So you see, we got everybody up to date. Before, there were some holes and gaps. After the view change, everyone became up to date. But two things happened. First, everybody detected. Then there was a view synchronization, meaning the majority agreed who the next leader is. And once the leader itself synchronizes and understands that it is now its time to be the leader and it has a support of the majority, it looks at the content of the view change message or the content of the log of each replica involved, and then it proposes what needs to be preserved. Yes.
Is there like a prepare message or a commit message?
Prepared.
Like true also prepare a message to anybody.
No. What we said, and this is a subtle point, we said that if we have 12 plus 1 replica who said they have prepared, then we could potentially guarantee that, or we could now, it's possible that one node has committed, and if one node has committed, then it's possible that the client see the transaction as committed. But even if a single node prepares it, it's not a conflict. There's nothing wrong to take it, because if somebody's prepared it, then that means if somebody prepares it, it's unique. Nobody else could have done it. It's possible that it wasn't committed because I was the only one who prepared, or we were the only one who prepared. There's nothing wrong to preserve it. So it's also okay to not to preserve it. That's why this new view may not be unique. That's why this new view itself needs to be prepared and then committed itself, just like a normal flow of the protocol. Because the new view may not be unique, because it could have dropped this as well too. I mean, it doesn't. I mean, it could have potentially even dropped this, because it's not 100% required, depending on the sort of the signatures and proof and certificates that are there. So, yeah. Yes.
Drop that has the one. It's the means that you very well says there's no thing happening on T1.
Again, depends. I mean, maybe this is not a perfect example for that, but there could have been, imagine, for example, let's say this one said nothing happened. This is faulty. I mean, it could have said whatever. Imagine this one said nothing happened. Okay. Then I could have taken the first 3, and in the first 3, for example, there's no R4. Even though I have received this message, the new primary may have received all 4, but it could have shown this as a proof of what should be the new view. So in that way, it will drop R4, and that's okay.
Guaranteed it should be correct.
It is only guaranteed to preserve transactions that were committable. It's not guaranteed to preserve a transaction that was a single person prepared. What's the point? Remember, that's why we had the commit phase, because if you were the only one who were prepared, you may not be included. I mean, it might have been the case that this message was never arrived, or it might be the case that it arrived and primary ignored it. All of those are possible. So it's not an incorrect, it's correct. But the guarantee was only preserve transactions that were committable.
Other sort of the time sequence, is it so like so is it something like set for time, or is it just until this majority? And my question is, like, all, is it only the new primary that requires a time sync to get a message?
No, all of them. This is time sync for all of them. These yellow are the time sync. All the replica are synchronizing. This realizes that majority have requested a view change and also realizes the next primary is R1. This also realizes same thing. And so all those yellow points or the orange point is a synchronization that every replica arrives at.
So how does one, like, know that the other also, like, follows it? Because they're not communicating.
Well, they all, no, this received 12+1 view change message. That's when you get to that point.
And so it means that you have to wait till everyone is got their message.
No, no. See, so let's just look at each of these individual points. This point, what does R3 knows when it arrives at this point?
So it mostly got view change messages.
From majority. Okay. So then R4 knows that the majority have detected a failure, the majority have done a view change, and the majority agrees who the next primary should be.
Yeah.
Okay. All right. So that's all it knows. That's the information that R2 knows, and that's the information that R1 knows. They're not aware of each other.
Yeah.
They're not aware of each other.
So in this example, so the new view is being done by the view primary.
The new view is done by the new primary.
So like, let's say R3 was supposed to be, like in this specific example, let's say R3 is supposed to be.
Oh, no, just use this one. Make the other changes.
Yeah, so like, let's say R2 is the first one to receive all the messages.
Yes.
They send the new view messages before the others.
Okay, so now, so let me say, so what you're saying is, let's assume this point, let's say, was here, like before anybody else. And this one send out the new view, quote unquote, prematurely. Is that what you're saying?
Well,
Yeah. But remember, the new view has the proof of all the view change messages received. So these ones, essentially, you could think of it as a certificate of all these view change messages. So if I receive a new view and it's valid, there's a certificate coming from 12+1 replica, then I'm synchronized. I can skip that middle phase. That's an implicit.
okay, so that means the time sync is only.
We haven't really talked about it. Still, there's a subtlety in this, why we need this. This is the most important aspect of all of this consensus protocol. I would say this is the most important aspect of PBFT, that time sync phase. These are good questions. Other questions? Is your question answered? I don't think so. So what's your question? Now, this maybe is a little bit better picture to maybe express it. Maybe not. Forget about these ones. Let's not focus on back. Let's bring our focus back to this time synchronization. People in the back. Questions? Yes. 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 It doesn't know whether R2 and R3, it would never know whether R2 or R3 received it. It will start, but since these green lines supposed to have a proof that I've collected 12+1 view change messages, these are, you can think of it that it's in this variation, these are certified. So if I see a certified message, it has a proof that 12+1 have view changed. So it allows me to essentially view synchronize and state synchronize at the same time, basically. Yes.
Synchronize first and then or review, or do you just push whatever and then decide later that it's reviewed?
No, you have to synchronize. Either maybe think of it this way. At this point, you synchronize. and you directly getting messages from the replica. In this ones, if you haven't got a direct message, you can think of the primary is sort of aggregating all those view change messages, and it's sort of passing it to you. So it's sort of an aggregator. So it's almost like if you had received all the ping one on your own. So it would be identical. Yes.
Theoretically, like, if from R3's perspective, if R3 didn't get any of the view change message, didn't get the time sync, as long as R3 receives the new view message from R1,
Yeah.
it's all good.
Yeah, because that's just, you can think of it, that's just identical as getting 12 plus 1. It has the proof that there are 12 plus 1 view change messages in the back, and then I'll come to it.
View time. We just discussed that R1, let's say, if it gets to a plus one, it can start doing.
We need it for unhappy case. Think about it. I'll come back.
Question, R3 receives all the view change messages.
Yes.
And other nodes do not do. Then
Yes. Which other nodes? You mean, I mean, then the primary doesn't receive it either. So this is the only node that gets to this stage. Okay.
then R3 will just proceed to other.
So that's one reason. Yes.
Doesn't even matter if we know it's a delay or they,
We never know whether it's delay or not arriving. We never know.
it's just, if you have the nodes that are synced up, then you proceed to having a view.
Okay. You have to be careful what you're saying. So I'm synchronized. I don't know whether they synchronized. So I arrived here. And even in this picture, I arrived here. The other one haven't even arrived. So they're not simultaneously met. Yes.
So the new primary is predetermined. So after if we switch to a new view, then R1 is selected as the new primary, and if it gets to a plus one sort of like view change message, then it sort of starts a new view, right?
Mm-hmm.
Like a possible optimization would be that.
Let's not worry about optimization. Let's look at understand the protocol. And the question is what she asked. Why do we need this?
Yeah, because if R1 doesn't receive 12 plus 1 view change message, then it has to go to the new view. It can't just keep waiting for R1 to receive 12 plus 1 message.
Why do we need this then?
My
Go on.
question is,
No, finish your sentence. I thought you were done. Finish what you were saying.
R1 can't keep waiting forever to receive 12 plus 1 messages, right?
So what is the role of this? What is the role of this?
That each and every node, either it joins the quorum or it detects a failure, and R1 knows that the majority has detected a failure, which is
Okay, let me ask you. If you didn't have this, would we face a difficulty? If you didn't have this yellow. Think about it.
it almost sounds like when we're getting a message of sure, every node just one different messages before it knows not because just one message. The other nodes knowing that everything wrong. In this example, I don't see if we're driving communication in time. So how does we know the other node? I guess like if they're just all that's like what defines the balance of the time.
So here is the key point. And I think goes back to the question that she had. I sent this message. What if I don't get any other message? What do I do? The other point, that's one phase of the protocol. That's one region of the protocol. I have sent a message, a detection, a view change message, and I don't collect enough messages. What do I do? The other one is I have received a core of 12 plus 1 view change message, but I still haven't got anything from the primary. So I could time out in this region I could time out in this region again. So what do I do if I time out in this region? What do I do if I time out in that region? And so basically what the other saying is, we're saying we will have a different behavior of a timeout depending whether it's before the time synchronization or after the time synchronization. Because again, what happens if I don't get enough 2f+1 messages here? I only send it, nothing happens. What do I do? That's one. Here, well, I got 2f+1 view change messages. I'm waiting for the next leader to propose, and it doesn't propose. What do I do?
So in the first case,
Let me just, I'll come back to you.
The first part, but the second part, if the replicas don't receive the review messages, wouldn't they just send out a detect failure message again and choose it?
Okay, so now in this case, they're gonna detect the failure of the new primary. Okay, so that's important. Why is it that at this case they cannot detect the failure of the new primary? That's the most critical point. Why is that?
Because it didn't send out the review messages.
Because now they see there has been enough evidence that the primary should have, I mean, they don't know whether the primary got it or not. But now they know there is enough evidence in the network, and so now they expect the primary to send it. And it's possible that the primary didn't receive it, and in this case, it hasn't received it yet. So now their timeout is primary had all the necessary information to get us to the new view. And at this point, if the primary doesn't propose it, we're going to do another view change.
so basically, there's two cases for time. So when a certain of the first active or 2f+1 errors, time sync allows to say, okay, this is the allowed amount of time for the new one to respond and say yes, we do as well. So that we can all the view change together. But if it doesn't happen, that's when another view change can get triggered saying, well, okay, this much time passed. I receive 2f+1, meaning the new time is full, and another round of view change to the next consecutive view.
Mm-hmm.
And one more question is, if R3 doesn't receive 2f+1 view change messages and it receives a new view message, that's also.
That's the equivalent. So imagine, so again, as I said, a single green line for now, assume a single green line is equivalent to all of these pink lines. So is it,
R2 and R3 does get 2f+1 messages, that is basically a recovery mechanism that in case the primary hasn't received it, if it receives 2f+1 and it doesn't receive a new view, it indicates that, okay, the primary hasn't received 2f+1 new view messages, so it has to.
no, it's concise. Go back, make it concise. What do you want to say? Because you circled.
So what I want to say is, the main reason why R2 and R3 is necessary for R2 and R3 to get 2f+1 new change messages is to basically ensure that if the primary doesn't basically trigger a new view message, then it can change the new primary again, right? So
Yes, but you can refine that. There's a little bit, there's something else there that almost there you touched it, but you didn't touch it yet. Almost. Let me go back to you. Does your question still there? Can you formulate your question? Not saying the answer.
Question.
Yeah, so what was the question? Is that, can you express now?
How did they delay or they actually didn't get it?
Well, we don't know. We never know. So that's, we can never know. Okay.
Now,
And we may get synchronization at different point.
Yeah.
And we don't know whether, I don't know whether others have got it. I don't know whether they will get it. I have no idea. I just know that I synchronized. People in the back, questions? Thoughts?
I'm sync is not a timeout range, and it's like a state.
It's a state, but it determines what shall I do for a timeout. So as she said, if I get to this point Now I expect to get to the, I'm expecting to get a new view. And if I don't get the new view with some timeout, I'm gonna try to fire that primary. I'm gonna try to blame it.
We are not answering that.
So that's the next question. Is that question, is that one of your question or no? People in the middle, today you're quiet, that row. Okay, so tell me where are you lost?
Stupid question before that. How long does this whole process take in real time? How many seconds does it take in our deployment?
It depends what the timeout is. If the timeout is an hour, then probably some factor of that. If the timeout is 1 second, 2 seconds, then some, essentially, I sent a message and I expect others to receive it, and then they send me a message, maybe it's 2 delta or 3 delta, depending how you count it. So it just would be some order of whatever the timeout is.
Check what is the question right
No, the question is that the question is on you whether you have a question or not. I kind of know the concept, so I don't have any questions.
now. Question. So she answered the second case, which you.
So chance, yeah, so that was the important point. As soon as I get to this point, if a timeout happens, I blame the new primary.
Yeah.
So how about in this region?
In this region, there's two cases, but one case is mine and I is lost.
You don't know whether yours is lost. How do you know whether yours is lost? You have no idea.
Yes. Case.
That's not a case. Because you don't know whether your message is lost or not. How do you know?
Yeah, I don't have.
So that's not a case. So what's the other case?
The primary didn't.
But that's the important point. You haven't got it. But you haven't got it. How can you expect the primary got it? You can't have an expectation. If you haven't received 12+1 view change message, on what ground can I assume that the primary would have got it? Here, I had a ground. I said, I received the 12+1 messages, primary should have received it too. And if he didn't receive it and didn't respond, I'm going to do a view change. I'm gonna blame on the primary. But here, I haven't got it myself. So if I haven't got it, then there's no evidence or there's
Technically, this can happen, this region can happen up to the next second primary is small.
but that's going to the next primary, you have to get to this point. The
Yeah.
question is, what if we never get to this point? That's the question. So we're not, you're kind of saying, well, this may fail. I may get to the synchronization time, F times before finally I hit a good primary.
You never witnessed what.
Yeah, so I'm talking about, so we now talked about significance of the view, part of the significance of this time synchronization, because the moment I reach this point, now there is enough evidence for me to expect that the primary should send a new view. And if the primary doesn't send it, I'm going to go to the next primary.
From the point of view of things,
Mm-hmm.
there's in the view change portion. We transmit the view change for the same view. If the timeout occurs in the time change portion, we do a change.
Exactly. So that was all it was, this whole 1 month and a half in the other class. Just retransmit. All you do, there's nothing else you can do besides retransmit. You retransmit indefinitely because here messages could be dropping. Maybe the network is unreliable. So you retransmit indefinitely because you haven't got the support yourself. But the moment you got to this point, you know that majority are vouching for the next primary. Primary should have received it, and the primary doesn't send a new view. Then you go to the next primary. By the fact that you have this time synchronization, it also means every time before you flip out, try to go to the next primary, you already got 12+1 in sync with you to some extent. So at most, there could be one at most, in this case, if this node times out, at most, the only thing that could happen, one node are now aiming to have R2 as the next leader. Everybody else is still trying to work on R1. So at most, the sort of the gap is just one. So it wouldn't be arbitrarily. You won't arbitrarily. So I don't time out, go to him, and then go to him, her. I don't arbitrarily move out. So if I'm planning to go to him, if we're all planning to go to him, I would only time out from him if I know the majority agree he's the next leader. Then I would say, okay, give him 3 seconds. If he doesn't propose, I'll go to the next view. And if he doesn't propose, whenever I realize the majority agree that he's the next primary, I did view synchronization. This is view synchronization. The moment I did view synchronization and he doesn't propose, I am going to go to the next one. It's possible that everybody else still thinks he's the primary, and it's possible that he does send a new view and it works for everybody. And I kind of went ahead and I'm going to backtrack. But it will never be the case that if I think he's the next primary and everybody else is still think he's the next primary, I'm going to get stuck on him. I'm going to be in this phase now. And I'm just going to keep sending him be primary, be primary, be primary. And I'm the only one. I never get to the sync point, so I never get to you. So you become the barrier step. So this is essentially a barrier step to avoid people just arbitrarily trying to think somebody else is the next primary. Because you always, before you try to get to the next primary, you need a quorum. I may kind of time out prematurely from him, jump to you, but then if everybody still is on him, I won't be, I'm going to get stuck on you. Retransmit indefinitely.
Time bound for time. How do we determine that?
It's the same timeout. It's the same timeout.
So let's say R3 happens on first, but it moves to the next view.
Yes.
Soon after that, R2 and R1 receive the plus one for the previous view. And R1, since he's the primary and we're not ensuring if others were synchronized. R1 is not ensuring if R2 was synchronized.
So let me so this one would kind of try to go out, go to the next one. Now it's possible that these ones don't time out. They get their messages on time, and then they get the primary. The primary proposes it, and enough people also agree, and everything is happy. And this one is became sort of outlier in the wrong place, and that one can come back if it sees the previous view is now progressing. It could potentially come back, or it could just get stuck there, wait till eventually everybody moves to R3. And while all of that happened, the only thing that it will do says R2 be a leader, R2 be a leader, R1 is an active leader. He says R2 be a leader. As far as everybody's concerned, I may be malicious, so I will be ignored. It's just gonna so put it simple. I'm gonna get stuck thinking he's the next primary, and I keep retransmitting, but everybody else is moving with him. If that's a good primary and is able to make consensus, so I'm essentially in the dark, but in future dark, for example.
If that happens in aren't we losing out on the
Just one, no. First of all, only one, I got one ahead by one, and the other one is progressing, and I'm going to retransmit to R2, so I will never get to R3. So I'm going to get stuck into R2 until eventually he times out or everybody come to R2. Then I can potentially get timeout in R2 again, go to R3. Like I get stuck. I won't be able to arbitrarily go ahead to R3, R4, R5, R6, R7. You need a core. You won't be advancing on this. You have the majority also now detect failure from him. So you get stuck until you have the majority behind you. Yes.
I assume that like some primary is like so I won't be seeing anything from it.
Yeah, you could simple protocol. You're thinking the next primary is R2, you're not gonna backtrack. Let's just simplify. You're not gonna backtrack. You think R2 is the primary. Everybody thinks he's the primary, R1 is the primary, and he's proposing and he's making consensus and he can form quorums, everybody's happy, and as far as everybody else is concerned, I'm a malicious replica trying to change the leader, and I will ignore it. Until everybody decides to come to R2. And the only thing you will do, you just keep sending R2, keep sending R2, keep sending R2. No, that's optimization. That's optimization. It's not necessary. Because that's kind of foreseeing that there's going to be enough failure. But it doesn't have to do that. It could just wait and eventually everybody will time out. Other thing is just an optimization to make it happen faster. Yes.
I'm out before the type sync to transfer the view change.
Retransmit, not I'm not sure. Retransmit, yes.
Broadcast the view change to everybody.
The same. They rebroadcast R1. Be the view change, yes. The same message again, yes.
So then after the type sync.
They now go to the next one. So now after the time sync, if R1 doesn't send a new view, now they're going to send the view change to R2.
Yeah. Then
So I'm going to go over this in more detail. So it's possible that there's some nodes are timing out, some nodes are timing out, and then they all get synchronized here. The new primary send a message, but all of these don't receive the new view primary at the right time. So they're timeout again. They send the view change message, they sync, and now the next primary will propose. And in this case, if this node sends view change and it hasn't synchronized, it will just repeat. It will just repeat sending it till get to the synchronization point. The moment you get to the synchronization point, you put a timeout, meaning you're expecting the primary to propose. And you expect, let's say, to primary propose in this region. The primary doesn't propose in this region for whatever reason. Since you've already synchronized, you're going to get timeout again, asking the next primary to propose. You get another view change. You synchronize, and then finally, the next primary proposes.
So when the queue starts from report that failure, and then get to say which one. So when the queue starts from report that failure, and then decide who is the next primary and step, then we can bring.
Yeah, so this is the part. So you all synchronized. You expect the R1 to propose. These messages arrives late. They all detect failure of the new primary. They send more view change messages. They now synchronize again, and then the new R2 now begins to propose the new view. So we go over it again, but that's the study.
Soon after all other nodes achieve their 12+1, they send it to the new and go ahead.
But what I mean, the primary is faulty, you could ignore that. If the primary is non-faulty, we should have received the same messages that was sent to everybody too.
Then we move to the next group.
Well, you do the same thing right now. We don't send that extra message. I synchronize, I expect you the next primary, I expect that you synchronize. If you're not, I just blame you and I go to the next primary.
But I think that's not said they would.
Wouldn't help anything. Wouldn't help it. How would it help it? Well, first of all, what problem are you trying to solve?
Also, other things not knowing. Majority of them.
Well, it doesn't really matter whether other nodes or not. I've reached this point, I expect the primary to propose it. Now, whether I know this one is reached it or not, I mean, they could tell me that it reached, maybe it's lying, but either way, we expect this one to propose, and if it doesn't, we're just gonna go to the next primary.
Penalty does not, what is penalty? It is the. It broadcasts the news as well. So.
What problem are you trying to solve? Are you trying to optimize or are you trying to understand the base? Forget about optimization. If it's an optimization, forget about it. Let's understand the basics. All right.